To understand how New York built the most recognizable skyline on Earth, you have to look down at the ground beneath it. The city is a towering giant, but its foundation is trapped on a surprisingly tiny sliver of rock. In 1624, the original Dutch settlement of New Amsterdam was entirely horizontal. The early colonists built low-slung wooden houses and trading posts, focusing strictly on immediate survival and securing a foothold at the edge of the water. The core problem they faced, and that every generation after them would inherit, is a matter of strict geometry. This animated map outlines Manhattan Island's exact boundaries. It is a rigid, waterlocked landmass totaling just 22 square miles. The edges cannot move. By the 19th century, hundreds of thousands poured into this exact footprint. The city physically ran out of space. The defining trait of New York's history is a 4-century architectural war against geography. With no way to expand the physical land, the only remaining direction was up. When British colonists took control, they imposed formal, grid-like street layouts. This systematic approach rapidly accelerated development, pushing residential neighborhoods outward. This photograph shows the 19th century response to that disappearing space, the brownstone. To pack a booming middle class into standard city lots, architects eliminated the space between structures entirely, building these heavy residential townhouses wall to wall. Then the Industrial Revolution arrived. Massive new factories, warehouses, and steel mills had to be crammed into this already saturated grid, competing directly with crowded residential blocks for the exact same square footage. The obvious answer was to build taller, but physics stood in the way. Traditional structures relied on load-bearing masonry. If you stacked brick too high, the sheer crushing weight of the upper floors would cause the bottom walls to collapse outward. The city hit a physical wall. The horizontal land was entirely exhausted, and vertical growth was mathematically blocked by the limits of brick and mortar. The island was locked in total structural gridlock. To survive, New York required a material miracle. That solution emerged straight from the foundries of the Industrial Revolution in the form of a single, highly refined metal, steel. This diagram shows how steel broke the deadlock. On the left, a traditional thick brick wall absorbs the building's weight, bowing under pressure. On the right, a rigid steel grid efficiently channels that weight away from walls, transferring it straight down into the foundation. Looking closely at this technical photograph of early high-rise construction, you can see the raw application of this concept. Notice how the dark, intersecting beams of the steel skeleton rise completely independent of the masonry exterior. By separating structural support from the outer skin, architecture was no longer bound by gravity in the same way. The vertical barrier was effectively erased. Look at the sharp, ship-like prow of this structure, rising above the street. This is the Flatiron Building under construction in 1902, and it served as the ultimate proof of concept for this new architectural freedom. The Flatiron sits at the intersection of Broadway and Fifth Avenue, a bizarre, razor-thin triangular plot of land that was previously considered entirely unbuildable. Steel framing allowed architects to maximize the internal volume of this awkward shape right up to its extreme edges. The Flatiron proved a crucial point. Extreme height was completely safe and could adapt to fit absolutely any restrictive space the crowded city possessed. Once the blueprint for extreme verticality was proven, utility quickly gave way to ego. The race toward the sky morphed into a fierce, competitive display of corporate wealth and global power. You see this shift from utility to luxury in this image of the Chrysler Building. Focus on the metallic eagle gargoyles and the intricate spire. The Art Deco movement weaponized style, proving the ornamentation of a skyscraper was becoming as important as its sheer altitude. The absolute champion of this era was the Empire State Building. Looking at this photograph, the immense scale of the tower entirely dwarfs the surrounding low-rise city, creating an almost surreal contrast of power. Achieving these heights required astonishing physical risk. This image captures a worker balancing freely on a narrow steel beam, hundreds of feet above the hazy streets, entirely without modern safety equipment. In a remarkably short window of time, New York's skyline evolved from a frantic solution for physical overcrowding into the ultimate global billboard of ambition. Following World War II, The heavy masonry and ornate crowns of the Art Deco era were cast aside. This photograph of the Lever House captures the shift toward modernism, defined by sleek, flat, and highly repetitive glass grids. This minimalist design was driven by pure economics. These glass and steel boxes required thinner exterior walls, which maximized open, adaptable interior floor space, creating highly efficient environments for corporate commerce. The zenith of this modernist philosophy arrived in the original World Trade Center. As seen here, these two massive, unadorned columns dominating the lower Manhattan harbor were engineered strictly for economic volume, projecting absolute global dominance. Architecture had shifted its primary function. These high-rises were no longer built to house a local population. They were precision-engineered engines, built to house the global economy itself. A skyline is never completely finished. Its ultimate test is how it absorbs and responds to profound cultural shifts and devastating tragedies. One World Trade Center stands here as a monumental expression of resilience. While the engineering is a feat of modern physics, the design functions as a deliberate physical anchor for recovery and renewal. Now, the city faces an entirely new set of physical constraints. The next generation of towers is focused on conquering the realities of climate change, relying on green technologies and smart building systems to create sustainable vertical ecosystems. The physical island of Manhattan hasn't grown a single inch in 400 years, but by constantly adapting its materials, stripping away limits, and pushing its architecture upward, human ingenuity guarantees the city will always find room to rise.